Hey, hi guys. Sorry for the delay. 1 minute. Yeah. So let's go to this collab. Okay. Have you gone to this collab? Which collab have you gone? Copy link. So we will see few questions on softmax and okay, we'll see at least two data sets, and based on that we will solve a few questions on logistic regression and softmax and all these things. Okay, so 1 minute. Let me share. Okay, so we are going with week 7 solve with instructor. Let me know if you can't hear me or if any problem is there. So we will load a few data sets. We'll do a little example of face recognition maybe, and we will carry on. So first of all, what we so we are not. I don't think you will require the NVIDIA notebook or anything. So I'll just start from the Pi Forest. So first things first, we are installing the Pi Forest module. 1 minute. So I'll copy the links here. Okay. Uh, is this going to be a can you copy this link? I mean, can you see this collab, everyone? Have you gone to this collab? Can anyone respond at least? I mean,
So I'm just getting an empty collab from that link.
okay,
Yes, sir.
you're getting an
Yes,
empty
sir.
collab, is it?
Yes,
Yeah.
yes,
Yes,
this is not that one which you have
I
shared.
think you have to refresh. Okay, wait, I'll if collab is creating a problem, let me do with a Google Doc. Even after refreshing, is it giving yeah?
Yes, sir.
Yes, sir. Yes, sir. This is empty again.
I don't know. I mean,
So can
collab.
you check the link once again? Is it the same?
Yeah, it should be the same. Okay, 1 minute. 1 minute.
Can you please share the link again?
Yeah. 1 minute.
Yes.
You need to do Control plus X after writing every line. Why? Anashita, what happened? For
Sir,
saving, is it?
yes, sir. Otherwise, no one will be able to see.
I think better to use a Google Doc than Anashita. Wait. I mean, it's supposed to be made in a collaborative manner. 1 minute. Huh? It's not getting synced. Mhm. Check whether you can access this doc file. Okay. Now you can access, right? So we are installing this module called PyForest. Then so after that, so this is the first data set which we are going to talk about. That is the face recognition and verifying people in a photograph. So what happens is that there are I'll just copy the thing in your 1 minute. I'll in the doc you can read the full thing. This is not this is not required to be copied. Just you can read it. So basically what is happening is that there are 10 different images, each of 40 subjects. So 40 people, of whom 10 different images of each are there. So for some subjects, the images are taken at different times, lighting variation, facial expression variation, facial details variation, like glasses or not wearing glasses, all these things are done. And all these images are taken in a homogeneous background. So that, I mean, that means the background is same, right? And the subjects are in the frontal position, right? So, and the image is quantized to 256 gray level and stored as an some integer value. So basically a numerical matrix form, and the loader will convert these to floating points, etc., etc. So these are basically 400 pictures, and the target is an integer from 0 to 39, indicating the identity of the persons which are pictured. Okay, so these 40 people we have to 1 minute. Someone's stealing something. Yeah. These 40 people we have to classify from their pictures. Okay. For this, we need to obviously load the data set. I will, so there is a target data set and the feature data set. Let me, so that is the first step, right? I'll give it in this chat window. Okay. So you have, there will be two numeric NPY files. Okay. You can check, you can download them. If anybody needs the doc link, just share with everyone or let me know. I'll share again. Okay.
Sir, how I can access this doc? I just joined actually.
1 minute, 1 minute. Can anyone share? I mean, yeah, just 1 minute. Can you check? Okay. So everybody
Yes.
just
Yes,
yeah.
sir.
So
Thank you.
everybody just download the data set and upload it in the collab notebook. Okay. Then, so what are the things we are trying to do? We will check the shape of the data set. Then we will see these images, these first 40 images or something we will try to see. Then we will write the code to plot the images whose index difference is 10, 10, 20, 30 and all those things we can do. We can use train test split, the shape of X train, X test, Y train, Y test, all these things we can do. Then you can apply logistic regression, softmax regression, KNN classifier and all. You can create a data frame which shows all the estimators with their accuracy. You can plot the confusion matrix for the result obtained. So all these things you can do. I don't think I mean everything of here we will be doing today. Okay, at least some portions we will do, but I'll just give you the remaining steps. Just try it out in your leisure time. One. So this was step 1, and these are the next steps here. Okay. So that is there. That now after that we will you can ask different questions like what is the shape of the data set. So these are basically like OP type of questions, right? What is the shape of the data set? How many labels are there in the data set? How many examples are there in each class? What is the shape of X train, Y train? Convert that into A comma B type, etc., etc. What is the accuracy? What is the F1 score? These are the normal things, right? Which we generally get asked in the question papers and all. So for first of all, we have to import the usual things, right? Import numpy as np, import pandas, matplotlib, matplotlib image, then importing the, we are ignoring the warnings and all. Those we will load at first. I mean, those we will import everything first. Let me, so from here starts the import parts. Okay. Then after that, so let me run also. Then obviously this is a code to, you know, upload everything, upload any select file and upload it. Okay. Anyway, these I do not use much, but in case you want to use code like this, you can, I'll just put it here. Okay. You can, what else you can do is you can just, once you have uploaded it here, so I have uploaded the faces, then faces dot faces underscore target, and then there is another data sheet which will come later. So faces dot npy that we have just now obtained. So that we can just we can see the shape of that file here. Okay. Maybe so here we can just write. We have down, we have instance, we have started a variable peaks equals to np dot load. What are we loading? We are loading the faces data set, and we are calculating the shape of it, right? So that is that's it here. Now so that shape which has come is 400 comma 64 comma 64. That is the shape which we have obtained. You can do remaining, you can do up to one. So you can check different values of the matrix array of the peaks array. Okay. But, and you can check what is the labels. I'll just give this course, but let me just cover this, and then I want to show you the pictures. Actually, what are the pictures that we are seeing? You can just see this. Then what we have is what are the another this is the target feature which we are loading. Okay, so what we have to do, as we told, we have say around 400 pictures, and we have 40 people. Okay, so 400 pictures are there, and that is in a set, and based on that we have to identify the people with their corresponding identity numbers. So one is 0, one is 1, and then 2, 3, 4, 5, 6 up to 39. We have to correctly identify the people's faces from their corresponding training data set, right? So these are the target data set. Okay, I'm sorry. Okay. I did a mistake. 1 minute. Let me just sharing. Just 1 minute. Sorry. Hmm. Yeah, sure. 1 minute. Yeah, so let me again share. Yeah, so what we should do is we have to copy, and so what yeah, so now the thing is we are keeping it, we are loading the target data set. Okay, let me take a use a copy, otherwise I'm working on the main data set, main collab, and everyone in the later terms also will use it, so better to make our own set. 1 minute, just let me upload everything. So what we have done till now is we have imported PyForest. You know what? Sorry. Before that, we had to install PyForest. Okay. Then what we had to do is we had to import PyForest, right? And after that, this was the data set which we have started with. Okay. And so we have done these things. We have imported NumPy, we have imported pandas and matplotlib. Now what we have is this is the picture data. Okay, what happened here? Cannot reshape.
Files, I guess. Is it
Sorry,
loaded? You have to reload the files, or is it they already there?
it is already there. Cannot reshape array of size.
So I think you have to reload the file.
Reload the data set, is it? Okay. That should not be the case. This is so anyway, after that, what basically what we have to do is we have to load the face target data set also, and then okay, so we had load okay. Anyway, and after that, what you have to do is we have to load the target faces target data set, and the shape of that was coming to be 400. Okay, now and you can see the different labels are there. So so these are the different labels of the data set, and after that what we are doing is we will see all of these pictures. Okay, all of these 40 pictures, first 40 pictures we are seeing. Okay, from there, and you can 1 minute, someone is saying something. Allow pickle equals to true. Okay, let me see this is the thing where we are facing problem, right?
Sir, I don't think you have uploaded from Google Colab. You've not run that line, I think, right? That cell.
Yeah, it is working, now. Okay. Okay. Now the thing is, so now up to where we came. Yes, so so this is the faces data set that we have we have uploaded here. Now what we are doing is we have the other data set, right? The target data set also, which we have. Now we have to again upload the faces target data set as well. Okay, now this is there, then what happened is we have the shape to be 400. So the target data set shape is 400. Okay. After that, what is happening is that we will try to plot all these data sets. So you can see that there are like this 40 pictures are there. So 10 by 4 rows. Okay, so these are, I think, the first 40 pictures. Okay, of the same, and you can see different what do you say, different contrasting images of the same figures, so that if you use any other if you use any other image processing algorithms, those also, I think, later for other purposes also you can apply here. For example, just like here it is bone, if you can put, I think, gray, if you put what comes is, 1 minute, let me get that to you, 1 minute. Huh? So you can have a grayscale image, or you can have a, I think, this VDD is something. The default and spectral was not working, but there are like 23, 24 other types of contrast settings which you can do. So I mean, these kind of things will come. Okay, so all the so you can do different image analysis maybe based on this data set. So although what I think is like we can work with some, we can make with some new data set also. And if it is like only 400 people, so I mean, it will be a good thing to reproduce this kind of experiment with a new data set. I have not tried it yet, but that sounds like a good opportunity. We can try that out. This is just a research problem, maybe, if possible, if you can try. Okay. Then, so basically we have, we'll just go back to the gray maybe, gray, we were using gray basically. We can use gray, the grayscale images. So these are these are some of these, I think, 400 images which we have taken here. Now from here, the target will be to identify the different, based on the training set, we have to identify the employees. Okay, employees of the company, which we from 0 to 40. Okay. If anyone joined recently, does anyone need the doc link? Just let us know. I'll post it here again. One. Yeah. One. Ranjit, wait. I'll share. Okay. So what we have is here. These are the collab. These are the face figures. Okay. And we can actually see. So I actually do not understand for what purpose this was again put here, but you can put with a subtitle and all. You can put with a graph title, that what are the things we have done. We have, okay, so these are the first 40. These are the 40 people face data. Okay, so you have your first colleague, your second colleague, and so on up to 40. From starting from 1 to 40, we have the these are the 40 images. Okay, the 40 people whose images are there in the data set. So this is, you see, we have figure equals to plot dot figure. Okay, fine. These are just plotting the figures, right? Now what we have is, we have we are plotting the images equals to from the peaks array. And what is the, from the peaks array we are plotting, right? So what is the peaks array? Let us go back and see what is the peaks array. Peaks array is the faces data set, right? So from the training data set that we are printing here. Okay, and so based on that we are plotting the colleagues, and what is the what are the colleagues photos and their according identity numbers. Now okay, let us give this code first of all. If you run this code again, it will give you the same set of data. Okay. Now we can store the labels. So we have stored the images in the X data and the labels in the corresponding labels in the Y data. Okay. So one important thing is this NPY files. Abhi, if you have seen the NPY files, they are not actually. I mean, you need a separate NPY viewer or some separate Python program to view these images. Okay. So I mean, if you open them with Notepad, it will not run properly. So I think in Stack Overflow you can find some either some Python code to see all the images, or you can see some graphical user interface. I was seeing in the GitHub it is there, but you have to install, I think. So that also you can see whether it is there, whether you can use that to see all the images and verify the things. Okay, verify whatever we are showing here. And for making another sample data set like this also, it should be possible in that way. Okay. Now again we are doing the same things, the train test split, X train X test, Y train Y test. Okay, from the data set. So X is the peaks part, that is the 400 images, the training set, and the Y is the labels part. So what are the colleagues numbers and all. Okay. So again, we are calculating the, we are doing the train test split of test size 0.2, 80-20, and then we are calculating the data, the shape of the data. Okay. After here, it is quite, not much, I mean, conclusion was observed from here. But what they have done is they have just calculated what are the different train test shapes and all. Okay, so we'll go in the same way, but what you can do is you can try to actually identify, and if it is possible that whether we can identify from a training set a particular employee, a new employee or something like that, if it is or a random image is put, then what kind of whether we can identify it. If we can calculate that, that will be, I think, very nice to do. Okay. So we can calculate obviously the train test split and train test shape. Again, the same thing is doing it. No. So what they are doing is at the first image and so on. So they are calculating the estimated list and okay. So now they will be applying. So it will be applied logistic regression and F1 score. So before that, again we are doing X train. X train equals to, we are reshaping as X train shape first array. Okay, so the first element, then the second element into the third element, right? So 0, 1, and 2. Okay. Okay. Okay, so let us see what
Could you explain the step, please?
Yeah, that also I'm trying to understand. So see, basically what we understand, what I'm seeing is here that the 0th element of the X train, there
Flattened, like it is 320 by 64 by 64. So 64 into 64 is being done. So X comma Y dimension rather than three figures in X train. So it is 64 by 64. Each image is having 64 cross 64. So it is being flattened as 4096. It is multiplied.
Okay.
64 into 64.
Maybe,
Yes.
maybe.
Yeah.
I'll
So like the MNIST data, what we do 26 by 26. So we multiply that to flatten it. So it is being flattened. So number of columns will increase.
So it becomes 320 by 256, right?
No, 320 by 4096.
409.
Why 4096?
64 into 64.
Achha, okay. Okay, that is great. That is great. Thank you. Yeah, I also have not seen this program. That's fine. Thank you. Yeah, I'll share the code. Just try it yourself also. Okay. Okay, great. So after that, we are just seeing, okay, we are just defining two empty arrays. One is an estimator list, another is an accuracy list. Okay, fine. And okay, let us begin. put this also. Now, we are importing the same things, logistic regression, F1 score, then what is the maximum iteration, X-train, Y-train, and we have to calculate basically the model accuracy, and mostly by model accuracy only they are calculating, and they are appending logistic. Okay, let's see what happens here. From sklearn.linear model, we are importing logistic regression, and from sklearn.metrics, we are importing F1 score. Okay. Now we are defining logistic regression and fitting it on X-train, Y-train, and we have to calculate the percentage value of the LR dot score, which is the model accuracy that we are printing here, and we are appending with the logistic regression. Okay, this part I'll check, and you can start doing it. It's taking some time also. Yeah. So we are applying logistic regression here. Okay. So we are applying different for logistic regression, for softmax. These we are calculating the values, right? So the logistic regression model accuracy for this is 96.25%. Okay, 96.25%. If you, I think if you calculate also, you will find the same accuracy here. For another thing which we are here, which we are adding, which we are doing is we are we are now doing for softmax as well. So for softmax, if we do, we are again importing logistic regression. So the the value is, we are using multinomial class and SAG solver. Okay, I think I mean in the slides, I think sir has written about SAG and Saga solvers and all server tele. Then after that we are fitting X-train, Y-train. Okay. Then we are at calculating the softmax accuracy score. Okay, and we will see what is the softmax accuracy. Okay. Now, if you, okay, let me put it here. Okay. If we do this, then also I think we should find 96.25% only. Okay. After that, we are calculating different
So
means
I
like,
don't know why I'm getting an error. It's saying
where?
when I'm running the logistic regression,
Uh-huh.
it is saying array should be of dimension 2, whereas it is of dimension 3.
Array should be of dimension 2. Okay. Can you show us once? Maybe I'll stop sharing.
I'll
Can you
just put
show
it
us
on
maybe?
the. Okay, you want me to share?
Yeah, please, if possible, to
Yeah.
share.
I can do that. You have to enable.
Oh, okay. Okay. One minute. We can allow participants to share the screen. Yeah, can you check now?
Yes, I can share. I'll just do it.
Did you do the reshaping step?
Yeah, I've.
See, look at cell. Yeah, it's 3D. It's not 2D.
That
Okay.
in between the step which you are telling, na? Which
Yeah, it's 3. Okay, so there has to be a reshape. Right.
wait, I'll share the code again. Yeah, I mean, anyway, it is shared. Can you just check in the doc file? That code which I think what was his name? He was telling about us. Devopriyo was telling.
Yes, anything, sir?
I'll
No, I
stop
mean,
sharing now. Thank
yeah,
you,
you
sir.
can. Yeah, sure.
Okay.
Just I'll again share. I'll just highlight maybe 1 minute. Let me. Can you find it? I'll highlight.
Yes, this,
Mm,
okay, yes, sir. Thank you.
yeah, this where was it?
It's
Yeah,
there in the document, right?
yeah, this one.
Right, sir. Thank you.
Just check once. Huh. So if we do a where were we? We were doing the softmax accuracy, right? Yeah. So if you do a softmax accuracy, then also it is coming to be 96.25. Fine. So that comes up to here. So both are giving us 96% accuracy. And you can calculate. So this is basically going as a OPE kind of thing. So they are calculating different quantities. You can calculate F1 score. You can apply a k-nearest neighbor algorithm and k-nearest neighbor accuracy. So there also you will find there actually we are finding that the accuracy has decreased to 92.5%. Okay. So if you if F1 score is 0.9626, fine. And if we apply k-neighbor classifier, okay, then it is coming to be they are telling it is coming to be 92.5. Let us check once. 92.5. Fine. So here the accuracy has become low. Okay. Now if we apply a grid search CV. Okay. If we apply a grid search CV, and then also what are the best parameters? Okay. So for KNN, so that is what we have seen also before, right? That for KNN the accuracy was less and compared to both logistic and regression and softmax regression. For grid search CV, what happened is we have applied grid search CV on the parameters, and the best parameters are coming to be the one. Okay. Okay. Can anyone explain? I mean, what is this part which is coming? I will also have to see. But this part, can anyone any thoughts on what is exactly happening here when we are applying grid search CV? This code.
So we pass multiple parameters of the neighbors. So we go from 1 to 11. And then we do once we've instantiated k neighbors classifier, then we fit it onto the model with the grid search of the parameters and multiple folds, 5 folds basically.
Yeah. So basically, yes, exactly. Thank you. So basically, what is coming is that the number of neighbors which are best fitted, best fitting to our requirement is one only. Is it? So that up to one neighbor we can pick for.
Yes, that's the best parameter out
that
of
is
all
best
the
parameter.
yeah.
Yeah. Thank you, ma'am. Thank you. That's great. Yeah. So yeah, we can try that. 1 minute. Let me. Yeah. Let me go up to, and this is when we are applying grid search CV. Okay. And after that we have the, so basically this is just making a chart of the whatever we have done till now. Okay. Anyway, you can do that. And there it is ending. So this is basically the way of calculating the facial recognition and whether which one gives us a better understanding, better checking capacity of the given data sets. Okay. Of the given of the given data set, which algorithm gives us a better accuracy. So that is one part. Okay. Now after that what we are doing is we have another data set which is on insurance. So basically you can read it. So the insurance industry they want to apply the data this predicting algorithms on the insurance industry. So they want to detect the risks early in the process to enable the better use of time and etc. and to predict future medical expenses of the individuals. That will help the company to make decisions on charging the premiums. Okay. So we have to load the, I will just put it here. You can load it. So this may be a good example, this things, okay, for the placement and all. We try.
So for the OPE also, we can expect like this two data sets on which we'll have to work.
OPE, there will be 5 data sets. Okay, there will be 5 data sets, and you have to apply your pre-processing. You have, so one data you will be given. So in the portal, there will be I mean, randomly 5 data sets will be allotted. One of the 5 data set will be allotted to you. Okay, 5 data sets are of same basically same columns, but different values maybe, or different position of NAND, different position of, there will be some differences. Okay, so similar data sets mostly. From there you have to first question will be which data set you have obtained, so that we understand for the later purpose, like what whether your answers are coming because of you got a wrong data set or something like that. That will be there, but that will be an unmarked question. Then the question will be to, you know, to do what, to do a to load the data set. Then there will be question to obviously there will be some dot describe type of questions, right? So what is the mean, what is the max value, what is the how many categorical variables are there, how many NaN values are there. These are the typical questions, right, that you expect. Then there will be a train test split which you have to do, and it will be mentioned that what train test split, which ratio, what is the random state and all. Then you have to apply some pre-processing algorithms. So there will be, and now the problem which we face here is that we want to say give different types of algorithms, but all the data sets, if we cannot apply as on a single data set multiple types of algorithms, right? So some so if we apply a KNN imputer, there is no point on applying the simple imputer again on the same data set, right? Or something like that. So what we have to do is sometimes you will see, read the questions properly. So what will be written is that this operation is just a dummy operation. It does not go with, with the flow of the program. So what will happen is that there, so suppose we want to do one operation on X train, and we do not want to carry forward that thing. So basic, maybe from the, we just want to see what is your capacity of, what is your capacity of doing the X train and all. So what you can do is you have to read the paper properly, read the question properly, and act accordingly. Okay, so some of the questions will be like you have to carry on with the question. So X train is this one, then X test is this one, and after that we carry on with the data set. But some questions will be there which will be like this is a dummy operation, and we are not carrying on with the changed data set. So some shape may change, something like that may happen, which again we do not want to. So those will be clearly mentioned. Okay, that do not go ahead with that particular data, something like that. And it is a problem, I mean, OP is frankly, I mean, we are also facing that what happens is that, I mean, how many types of operation you can, pre-processing you can do, or how many types of operation you can do on a single data set. Okay, so it is difficult to give like various types of questions. So that's why these this kind of dummy questions are coming and all. We'll see what can be done here. But so that is the basic thing you understood, right? So read the question first of properly, load the data set. Then first question will be that which data set you have obtained. Okay, Then you have to load the data set. You have to do some pre-process. You have to calculate the shape, this shape, that shape, whatever. Feature matrix shape, target matrix shape, this and all. Then what is the mean value? What is the standard deviation? What is this, that? Basic things. Then what is coming is that your pre-processing part. So there will be a pipeline, there will be a this thing, that thing, whatever you have done in week 2, right? So all those things that you have written codes for, you have your you simple imputer, KNN imputer, one hot encoder. So there will be NaN values. Now how do you approach NaN values? So those portions you practice well. Then you, what you do is you apply your week 3. Then comes week 3, right? So pipeline, how to make a pipeline, you have to know. Okay, because pipeline is quite important. So you have to make the pipeline, and based on the pipeline, yeah, and the thing is, I mean, there, based on your one step, the next step of the program is going to be affected, right? So you have to take care of that, that you should apply in such a way that the next step does not suffer, right? I mean, you have applied something at the previous step, like what just now happened, right? So Vivek did not apply the dimension, the reduction part. So that's why he was facing the issue. So that kind of thing may happen. So based on that, you should take care of how to make the pipeline is quite important, and you are doing a very I would say a difficult job of writing it from the scratch, right? So you have to be very cautious and very confident there. After that, you have to go to, so those things you do. Then you come to week 3. Week 3 you have a HTT regressor, and whatever other things are there you do, and you have to go to then week 4 and so on. So week 4, what you have to do is you have to see what are the, I also I should not, so don't know much. So those are the basic things. So read the question properly, and note exactly what it is asking to do. We try to make it as much as non-ambiguous as possible, but still there are sometimes so some possibility of, obviously it can be, but we have tried that so that no ambiguity should be there. So just
Sir,
check
and the parameters that we pass, we only pass the ones that you've mentioned, right? The rest of it we leave as default, right?
Yeah, obviously.
Yeah,
So
because in graded assignments, I've been losing
graded
marks week
assignment,
after
I'm
week.
telling you,
Yeah.
graded assignment, I'm telling you, it came first time. So there were so many issues, and I mean, what has happening is Friday, maybe sir was recording the lecture and we had to release it on Sunday. So that's why previous time also there was the these issues, and based on that we had to make the graded questions. So this time also this came, but yeah, as we are moving one by one, so we are trying to develop the graded assignments, and I mean, we are detecting the problems. Yeah, I mean, I understand. I mean, it's gradually trying to develop the course, mostly. So yeah, I know. I mean, week 5, as you know, I mean, 4 questions were wrong, so we changed accordingly. Week 7 also, one issue is there, but we will take care of that. So you need not worry. I mean, yeah, Sunita has told something. MLP OPE syllabus.
Sorry, that was my mistake, sir. I had to
Yeah,
paste
okay.
it somewhere and it got pasted
Yeah,
there.
okay.
Sorry.
Yeah, so MLP OPE syllabus is week 1 to 4 anyway. Okay, so week 5 onwards is not there. That will be in the next OPE. And I think today you have a meeting on the, today is it the Kaggle part? Is the meeting today, that meeting?
Yes,
Yes,
sir.
sir.
Yeah. So attend that. Okay, I'm also not exactly sure. I mean, I'm not a part of that Kaggle team mostly. Yeah, I mean, maybe gradually I'll be a part, but right now I'm not looking into that. So attend that, and so there, follow the rules. Okay, I mean, there are so some rules are there, like you can give maybe this term, or the once you finish this term, so something like that is also, provision is also there. Just listen to all the details in the Kaggle part. So that is also going to be another course, right? So Kaggle that you learn, and any of you sitting for internship or placement this anytime soon? I mean, like this July or something. I think, I mean, one diploma, once you cover one diploma, then I think you are sitting for those things. Is it?
I am planning to.
I mean, are you eligible?
Yes, I'm a direct entry diploma student, and I will be finishing this diploma this term.
Okay, because we will be sharing some, I mean, I'm trying to make, I'm not sure how long it will take, but we'll try, I'm trying to share maybe some details on TensorFlow. So TensorFlow, I think some JDs are asking for. TensorFlow and Keras also, if you learn, it will be good. But anyway, they will be coming in the, no, sorry, Keras may not be coming because what is happening is that in the portal, it is difficult to, run the deep learning programs now. So try to learn those things. So I think the placement team has already shared with you the websites which we are suggesting for going through some of the courses. Cognitive class is there. Then there is, if you get to see some of the Andrew Ng's lectures. Then in Coursera,
None of this was shared. Only the eligibility criteria was shared till.
Okay, you can. I'll just do one thing. Sorry, I'm deviating a bit, but just a minute. So you can check these things. Cognitiveclass.ai. This is a good website. I can show you. 1 minute. Let me. I have, I think, shared with the placement team. Anyone can start. Actually, you can start for your placement. So
I actually saw this on your LinkedIn profile yesterday.
Yeah, no, this is actually a good website. So I was doing TensorFlow, but you can do so. This see Kubernetes. So we are, I mean, discussing yesterday also that Kubernetes and Docker. So I think in IIT there is no course. Okay, in full IIT there is no, all IITs most probably there is no course on Docker and Kubernetes. Okay, on TensorFlow, Keras and Python there are no courses. So there is introduction to programming, which starts with maybe joy of computing with Python. So it is language independent kind of thing. Okay, but again, as you know, as you see in the JDs also, right? So there are they are asking for Kubernetes, they are asking for blockchain. I am not sure. I think Solidity they will ask for at present. Now everyone is looking towards Solidity and Golang. So these are free resources, and of course we have our older things, right? We have our Stanford Lagunita, which also you should see. Then you should see MIT OCW. This, so again, I think you know. So these are some of the resources. I'm not telling that these are required or you should all of you should do these things, but start you can start preparing. Okay, those who are in the trying to go get into internships and will be looking into JDs and all those things in the next few days or months. Maybe it will be a good, I think it may be a good good thing to do. Okay, so do start doing that, because as soon as you start preparing, it is good, right? There is no better day than today. So anyway, so we have to load. I mean, do that. We will start. We'll try to share a code on a notebook on TensorFlow, but that is not a part of this course. I mean, so maybe after the course we will start. Will share TensorFlow. You do Keras if possible. You can do Keras and PyTorch. Have an idea of those things, because in the JD they are asking, and as so although the courses are coming in deep learning theory, you will learn in the third year, I think. In the September those courses are starting, but before that also I think some of you at least may have some idea. But if you can do some study. It will be useful. I think 1 minute. There is a guy called 1 minute. PyTorch. So he is the inventor of PyTorch and Keras. I think Adam Baskin. 1 minute. Jeremy Howard. Jeremy Howard, maybe. Jeremy Howard.
No, sorry, that is fast AI, not PyTorch or Keras.
I actually
I was
forgot
actually
his
looking
name.
into fast AI, like maybe like I didn't start because I already have a quite a bit of load.
I
here.
just forgot 1 minute. Huh? Let me 1 minute. Sorry, I'm deviating a lot, but just 1 minute. Who? I mean, François Collet. This guy. He's a Google engineer. Okay, so he has a nice book. You can see this is his website. So Keras TensorFlow and yeah. So you can check. He has some papers and his book is quite nice. So there is it's a very I could not check it. I could not read properly. I'm trying to read it. So many books I have downloaded. So these will be. This is very thin book, I think. Okay, at least 200 pages, and this guy actually invented the full thing. Okay, so you can. I mean, I don't know. I mean, you can download the book, or if you can get the book somewhere. I mean, we should not share the pirated pirated link also, right? But you can, if you can get, it will be good to study. Otherwise, we'll try to share, and you can see whether it is somewhere in some library. But it is good to I think this may be good to read the book of the guy who actually wrote the code. Okay, he invented the TensorFlow. So TensorFlow, I think, will be yeah 425 on yeah, so 425 rupees. See, I should not I mean force anyone to buy any book, but maybe interesting to read the book. Okay, yeah, yeah, just check it out. And anyway, we'll be sharing some I'm actually, I can show you what we were making. But no, sorry, that is in my other account. So we were doing some on TensorFlow. You start with hello world. Okay, how do you write a normal TensorFlow matrix? Then you have to do you can do a linear regression with TensorFlow. You can do a logistic regression with TensorFlow. You can do maybe this what else we were seeing, the auto encoders, the the restricted Boltzmann machine. All those things will come later, right, in deep learning. So it will be useful to get an idea. Anyway, in the course they may be teaching, but still just get an idea of these things. It will be helpful, I think. And everyone is asking for everything these days. So the JDs are really which come to us. I mean, before it goes to the students, we have to see whether whether it is suitable for whether we have taught it. And so many of these things are coming. So you have to see, you can learn H2O. H2O is a data science platform. Then there is Tableau. I think till now we have not done any course on Tableau, right? Tableau or data visualization. Tableau may be important. And so those small things, na, if you just sit on a weekend and try also, it will be helpful. I think this is my personal opinion, but may be helpful. So data visualization, SQL, anyway you are learning. So SQL, you are solid there. SQL and DBMS. And yeah, I think that's mostly it. Then they may ask for something small things like Golang. Golang, some companies were asking. I think I don't know whether you have seen the JDs which are coming, which are being shared, but you can check. Huh? There is a particular section on discourse on it, right? Which shares the JDs and requirements. So you can check if it is available to you. You can check what are the JDs coming. So based on the JDs, I mean, what I would do is look at the JDs, look at least 10 to 20 JDs, and start studying the things which they are asking for. See, but do not select the, research type JDs. So sometimes this, I don't know whether you saw this IISc one JD came, that which talks about, the, you have to learn electronics and you have to learn communication, very specific. So that may not be a sample case. So take a large set of samples and try to identify what are the features they are asking for, what are the topics they are asking for. This basically I'm telling you, TensorFlow, Keras, PyTorch, if possible. Then machine learning, in machine learning you have linear regression, logistic regression, classification, k nearest neighbor, right? And if possible XGBoost, which will be treated in the MLT MLP. Okay, that you have done. Then DBMS SQL, PostgreSQL. That also you I think no. Then what else? Golang and basic statistics, mathematics. So you have done anyway. So yeah, I think that should give us some advantage.
These
Yeah.
JDs will only be shared towards the end when we set for the thing, right? Not in advance.
It is already shared with the students. So I don't know, maybe have you have you come to that part where where you are eligible to sit for internship and placement?
Yeah. So I got an email saying what are the criteria and like nothing else. Like as
So
per the criteria.
some JDs and so like this CS Shruti, one girl is there. Do you know her?
No, I'm not.
No, I mean we are arranging some meetings with the students, and we were
Maybe it was shared
discussing.
with the placement team only, not with the general
No,
students.
I mean from the placement team only. We were discussing with some students.
Yeah,
Okay,
there are
maybe
student representatives in the.
Yeah, I know. No, I mean we had a meeting few days back with the students on discussing JDs, and then now also we are sharing.
Like all students.
Yeah. I mean, actually, many students are there, and
so I'm a direct entry diploma student. Is it why I didn't get an invite?
I'm not sure. Can you just check?
Okay,
check with whoever. Maybe the support and the the IIC, right? Industry interaction. Just talk with her. Maybe Aishwarya or Barraju sir. They may be able to better help you, because I mean we were talking a lot these days on which JDs to share, and we were sharing a lot of JDs. And if you are eligible for internship, if you are eligible for internship, if you are you can do one thing. You can look into the one major part. You can look into the IITM research park companies also. Okay, I'm not sure how you will get it. See, if one thing you can do is you can go to the research park website. You can check the company list. IITM research park has a website. Okay, you can look into it. So all the company names will be there. So I mean this is a very daunting task. Okay, I know, but what you can do is you can look at all the companies, their descriptions, and you can choose which company you look for, who you want to work for. Like I know QNew, there is a company. So most of the companies are based on from mostly founded by IIT faculties. So they will be all mostly research based companies. Okay, I know one faculty from Gaurav Rayana who is offering internship this time on finance and fintech and data science. You can look into that. I don't know whether his website he has shared. He was sharing with the MTech PhD candidates. You can check that. You can check his website if it is mentioned. You can look into QNew. There is a company which works on quantum cryptography. Okay, so that also if possible. Then PyBeam works on I think automotive. Okay, automotive or something. So that you can check. So that will be a one way to look for internships, and otherwise just go with the flow here. There will be the JDs will be shared with you. I think once you come to the stage, they will share it. Okay. Yeah. Sorry, we have deviated a lot. Sorry. yeah, let's I'll upload the next data set. So I think you have downloaded and uploaded this one, that is the medical premium data set, right? So this is the medical expense data set which we are working with. You have age, then sex, then BMI, what are the BMI values, then children, whether he or she is smoker or not, what is the region, and what are the expenses. Okay, fine. So you have let's upload, let me upload the data sheet. Okay. Yeah. So let's see, we have a read CSV file where we are, this is the header file which you have already seen, right? The first five data points. Then again, you will be asked to calculate the informations. Okay, let me share the code. Then we have a data dot information also. So these will be required in your OP also. Okay, right? So they may ask which one, any of the columns have, does any of the columns have a null value? Which of the columns does not have null value? Acha, data visualization is important. Okay, for your OP. You should know the box plot, violin plot, then scatter plot. Okay, basic those three, 4 points, you know, right? Which were used in quiz also. So those codes just learn properly. Okay, how to plot a data violin plot. What is the difference between a violin plot and the data plot, right? And what do we get from each of them that we do not get from others? What is the thing that we get from a scatter plot which we do not get from a column or bar plot? Huh? Those are also small analysis, small insight. Okay, those will be utilized. Whether any graph has a, whether any column has an outlier value, right? So those will be helpful for your OPs. Anyway, then this step will be important, data dot describe. So you have to calculate the mean, you have to calculate the median and all. So they may ask what is the first quartile data, what is the second quartile, what is the maximum data and all. They may ask what are the, these are all OP type of questions. See, what are the type of genders which are available in the data set. So you can see that this is what are the unique values. So these are the in this column, these are the unique values, right? Minute. Oh, sorry. Then how many smokers are there? This also, this kind of things, one mark questions. Okay, this will come. So how many smokers are there? How many non-smokers are there, and so on. It will be there. Whether the what is duplicated? Data dot. So this means, I think, what are the duplicated data sets which we have? And then we will drop those duplicate values. So how do we do that? We have the duplicated, we see what are the duplicated data, then we drop, we do it in data 2, we copy the full thing in data 2, and then from data 2 we drop the duplicates, right? Then from data 2 we drop the duplicates and then calculate its shape. Okay. Acha. I think some of you may be part of the NPTEL analytics also. I don't know. I think yeah. So that also is going on. That is also one thing you can show, I think, in your project list, or if you are sitting for placement. I don't know. That looks like a very huge. That is a very huge data set, and so many issues are there. So complete pre-processing part. So we have data 2 dot shape, and yeah, so we can calculate the shape here. So what is the shape of the data? Oh, sorry. We can calculate the shape of the data set. Now categorical columns. So categorical columns are select the data types, exclude the number. Okay, so what was number? Okay, what was number? Okay, I'll check it. So what are the things that we have? We have sex, smoker, and region. So where are they? So sex is a female, okay. Smoker, yes or no, and region. So these are all non-numerical data or categorical data, right? So what we have here is the categorical columns. Again, obviously you understand this. And again, we have the number numerical columns, the remaining columns which are left. So we have the numerical columns here. So we have basically separated the numerical and the categorical values, categorical columns, right? Hurry, hurry, do not change the code. Okay. Then again, we are applying the we are applying the one hot dummies. Okay, so it converts the categorical variables. So what does get dummies do? Get dummies convert the categorical variables into the dummy or indicator variables. Okay, so we apply that on the categorical columns. So we convert them into numerical values, right? Then what happens? Now we have calculated everything. So now that we have done it, so what is coming here? We have one part we have defined. So sex is converted into two separate columns, right? So one is sex female and another is sex male. Smoker also we have converted into yes and no part. Okay. Yeah. So we have into yes and no part. Region also, region is classified into region northeast, region northwest, region southeast, region southwest. Okay, so the same one column has been separated divided into 4 columns. Okay, then we have the final data frame, which is okay. What happened here? The num calls is not defined. Okay, what is numerical column? Acha, sorry, I had not run that before. Okay. Acha, so we have concatenated that. What happened here? Let me see what is concat. Concatenate panda objects along a particular axis with optional set logic. Okay. So what happens is that it concatenate the pandas objects along a particular axis with optional set logic along the other axis. So we do that. We calculate the final data frame. We construct the final data frame here. Let me put the code here. Okay. And what we do with it is that we calculate the final header. Okay. Let me remove the 2. Let me check how many can. Okay. So this is the final thing which is coming up to us. So one is age, we have BMI, we have children, number of children, the expenses, then the categorical columns, they are classified into separate columns. So for sex female, we have 1, sex male, we have here it is 0. In the first row, it is 0. So basically a female non-smoker person from a southwest region, right? So that have she's aged 19 and no children. Her expenses 1884. But a person 18 aged, she has one child. She or is it a she or it's a he. He has a less expense, and the BMI is 30. BMI is high, 33.8. Okay, and she's from a which region? She's again from a southeast region. Okay, so on and so forth. Now we drop the expenses column. Okay, from the X data set, from the features data set, we are dropping the this column. Okay, this expenses column, and we are copying it here in the Y column, right? Okay. Now from the Escalon selection, what we do is again the simple thing. We do a train test split. Random state. So random state again in OP you will be mentioned. Okay, it should be mentioned what is the random state. So there will be either 17 to 25 or something like that is calculated, is given generally. Okay. For the people who came late, do you need the doc link? Yeah, sure. Why didn't you tell us, Ivanshu? 1 minute. Share. Otherwise, how will you do? Oh, sorry. It's not here. So sorry. Yeah, here you go. Yeah. So where were we? Yeah. So now that we have this, so what we do is we have the final data set, which is which we have classified into X and Y. X has the from X, we have removed the expenses column. This is the expenses column, right? We have removed this and we have put this in the Y, right? So from the Escalon.model selection, we again now we import we import the train test split and obviously calculate the shape. Okay, and from there what we have is X train shape, Y train shape, X test and Y test shape. Okay, the similar things which we are calculating. So basically you understand the template, right? So first load the data set, then then calculate the shape of the data set, then do a train test split with the, and what do we require in train test split? We have the random state values, we have the X train, Y train. Then you are asked to calculate generally what is the X train shape, what is the Y train shape, but how do we drop a feature, how do we make a dummy feature, how do you scale the feature so that it is it comes in the in our range of focus, and then you apply you apply the different algorithms to calculate different quantities, and maybe how fast the training ended, they will ask, and how which one was the better algorithm to solve this. This looks like the basic philosophy of the course and of the things which we are doing till now. That looks like the basic target of calculating. Apart from that, where were we? Yeah, 1 minute. 1 minute. Yes, so we have calculated the X train and Y train shape. Then again, we go through the same way. We have k neighbor regressor here. We are importing k neighbors regressor, and then from Escalon.matrix we import the mean squared error. Okay, now this is a new thing. So this is an important thing. So here, see, it will be important to at least remember, just check when it is coming, that when we are in the revision session or on, just ask this, or I'll also verify, ask this in the discourse also, that whether the libraries will be imported or not. Okay, if it is not imported, more if it is, take that as a case. Okay, just be ready for that. If it is not imported, then that you may have to import. Okay, so like you have to know from where we are importing the scalar, or whatever, where we are importing the pyplot as PLT or mean squared error. Okay, or from where we are importing the train test split. So you should not just forget the library name, that from scalar.model, if you write classification we import train test split, that should not work, right? Sorry, so that you should remember, at least I mean, as many times as you write the code, and I think many of you are writing the code from the scratch. I mean, which is great. I mean, as sir has not also shared the, I mean, we have not shared the collabs. Okay, so you're writing from the scratch. That is a very good practice. Okay, so you can just remember, when you are writing in the in the exam, that time it should come like automatically, in hand, like a muscle memory kind of thing. So if that comes, that is, then the, I mean, the goal is achieved mostly. Then so basically what we are doing here is we are importing the k neighbors regressor, and we are importing mean squared error. Okay, and from there we are now again we have we did everything in data 2, right? Because as you remember, what happened here is that in where were we? Yeah, we have dropped the duplicate values in the data 2 matrix, and so we will now work with the data 2 only, right? So what is the shape of the first element? So the data 2 dot shape of 0, that is the that is giving us 1337. So these are basic portions, basically different quantities which may be asked to calculate, and so on. Okay. And what is the square root of this of this? So that is that is coming to be 36.56, right? After that, yes, after that we are calculating the root mean square error. Okay, let me go there. Anyway, let's do it. Now RMAC we have defined as an empty array, right? And for the k in the range, we are checking the k neighbors regressor, and we are predicting based on x test, and which is the RMAC error. RMAC error we are calculating as mean squared error, square root of the mean squared error based on y test and y test of the prediction. And based on that, we are calculating the RMAC. We are calculating the RMAC error, and we will print it as it is. Okay, so for different k values for k neighbors regressor, right? So for different k values we are printing it up to k equals to 38. So as you can see, at first it was 11,786. At the beginning it is 11,454, so it has reduced as we have increased the k values, but in the middle also it reduced at k equals to 2 and all, it got reduced. Anyway, so this is the RMAC error for different k neighbor regressor which we are calculating here. Okay, so let me put it for your practice. Okay, name L is not defined. Okay, 1 minute. So L is defined. Sorry. So I have to give it here. So L is defined as the ceiling of the data to first element, right? The shape of the first. So let me give that code. 1 minute. Before going into RMSC, what you have to do is sorry, 1 minute. And what is L? L, you can calculate that L value is calculated coming to be 37. And after that, what we are seeing is we are seeing the RMSE value for different K values, right? So it started with 11,000, then it decreased to 10,600, then 10,000 decreased. Again from 10,005, again from 10,000 K equals to 4, it started to increase, and 479, 518, 710, and again so on, and I mean going on and on. And what is the minimum value of the RMSE that we have obtained? That is the 10,021, right? 231, which was there in the K equals to 4. So for K equals to 4 only, we are getting the minimum value of RMSE.
So why we are going up to root over L only?
Why we are going up to?
Root over the first dimension of the data only.
I actually have to see. I'll check. Okay. We can go actually up to above than that also. Okay.
We can, go up to how many ever data points are there, right?
Yeah. I think so. We'll okay. Can I check and get back to you?
Yes, sir.
Yeah. And Sudipto, I saw your post. Okay. Just yeah, let me do the week. What we can do about the week 6 thing. Huh? What I can do is
I have mentioned the question.
Yeah. I saw that you have mentioned. But the thing is, maybe next Monday and Tuesday I am not here in office. So after that I'll come and I only have to push it. So I'll do one thing which I can do is maybe in the before the next time at least I'll try to update it. Thanks for the feedback, Sudipto.
Okay, sir.
Thank you. Yeah. Thanks. That helped a lot. I'll look and try to upload it. Look into it. Okay.
Okay, sir.
Yeah. I mean, once I come back, the problem is quiz 2 preparation is then starting. So many works going on. Yeah. Anyway, so we have RMSE, and then yeah. So based on that only, and then you can calculate the refined error curves. This is the you can see that at K equals to 4, I think there was the minimum value which we have calculated, and based on so after that it again started to increase and so on. So basically this was the conclusion that they have obtained, that the RMSE value is minimum at K equals to 4. I'll just plot the thing again also. I'll can you just post this question in Discord, Sudipto? I'll ask around this.
Okay. I'll post.
Yeah. And just tag me and Jimmy. Can you tag me and Jimmy on the
okay, sir.
Yeah. I'll talk with him.
Okay.
He wrote the code, so it will be best to talk with him.
Okay.
I'm sorry, I again plotted a scene. 1 minute. Yeah, so basically mean of RMSE you can calculate from here. And where were we? Yeah, so the error curves. Yes, so the error curves you can define. What is the header file of the error curve? Not header file, the head of the error curve basically. And you can draw a plot of that. Okay. So that was the conclusion that we obtained. Then again we can do a regression for a large scale data. We can create a large data set having 10,000 100,000 samples and 50 features. You can split it using train test split. You can reshape it in such a manner that each chunk contains 100 samples. Then we import standard scalar and transform the features using partial fit method. We import SGD regressor and train the model. Check the accuracy, print the intercept, and check the value of the coefficient and intercept after 4th iteration. So on. Okay. So okay, so let's do that also. And there are so we will upload this collab. I'll upload the collab. I'll send it for upload maybe tomorrow or day after tomorrow. It will be uploaded. Okay. So just check this in this PDF in the portal. And there are few oral questions which they may ask in the Viva or somewhere. So you can look into this. What is the full form of SAG? What is the how the name of Manhattan originated, and what is the hashing technique? Okay, these are a little, I think, above also. I mean, not from only from this week also. How the softmax function and max entropy classifier works. Okay, this will be asked in the Viva. What is 1 versus 1? What is 1 versus just for multi-class classification? Okay, look into these questions also.
Sir, can I ask a question?
Sure, sir, please.
So, is there any reference book that we can refer to understand more about these solvers and
I am not
application in the context of
sure.
ML?
Best resource, in my opinion, will be the manual, the Skillern manual. Okay. So tell me, like SAG, right? SAG is a part of Skillern, right? Where did we, or Skillern is a lib linear? Okay. So let's see. SK, I think Skillern only, right? Skillern lib linear. So this is the, as far as I have seen, this is the best resource, sir. So you have to, what you have to do is you have to, you know, understand this part. This part, if first of all you try to understand. Okay. Once you do that, you check, you have a quite a good idea of this part. So what are the solvers like SAG, Saga? What are the algorithm for small data sets? This part you have to. I mean, I think they may ask you, or the in industry or somewhere, people ask up to here. Now, if we need more, you can check in the user guide. Okay, this is very interesting, and there will be all the mathematics related to it. Okay, so I think that is the best resource which you can get. That is the best resource which I have seen. Okay. Books I won't suggest, because I have not seen a book which contains everything which we are taught here, and also, I mean, these things update quite quickly, right? Another thing which you can do is then you can go into these references. Okay, so this is a very interesting book, and everyone is suggesting it also. So Christopher Bishop's Pattern Recognition and Machine Learning. Okay, this is a interesting book, and maybe I have not also checked it, but you can see if this book helps. But again, everything may not be same, and everything may not be exactly updated, or everything may not be there, but you can check this book. And again, see, basically what happened is this is the paper, I think, which came. Okay, you will go to here. This is from archive. So if you know, do you know what is archive? Archive is basically from Cornell University. So what happens is that all these peer reviewed papers which come in the journals, right? So they take a lot of time to peer review. And what may happen is that suppose this guy, Aaron DeFazio, he published the paper, and someone in say US, he's from India, Paris, someone from US have also I mean invented the same thing, similar thing like that. Then he submitted later, but his paper got published early, right? So what here we do here in Cornell is archive. Here what is done is I mean, if he uploads it in the archive, then everything is in open. Okay, so he can actually tell later that I have invented it earlier than you, and I am the primary inventor for this. Okay, so anyway, you can check all the papers in archive, but again, there are some I mean, how far we can depend upon archive, that is also a question. So anyway, you can check many of these papers from archive. So how do you go? Yeah, you can go here, I think. No. Yeah, you can download this PDF. Okay, so here also another thing is important which you are not taught. This is a research paper. Okay. this is a research paper. How do you read this? Sorry, I'm again taking 2 minutes. I'll take your time. So I'll just tell you how to read a research paper. Okay. So suppose this is the heading. Okay. You can check the heading of a research paper. So there are few things called few websites called one is called Scopus. Okay. Here you can go and you can check research papers. You can go to Nature. Okay. And you can check whether in Nature you have some research papers. Many of them will be open access, but open access costs the inventors a lot of money. So many of us, I mean, like my own paper is also not open access because I mean, then it would cost IIT to publish the paper a lot of money. So we give it in, give it, and if the institutes have access, you can check it. Again, this is teaching piracy, but you can check this website. I should not teach also. This is something called, this is something interesting. You can check what is this in the you know internet. Okay, there is a very huge court case going on right now on this thing called Sci-Hub. Sci-Hub is basically against the publication barrier. So anyway, leaving all that, first in a research paper, if you see in a research paper, there you see the heading of the paper. So you need saga. You need to understand more about saga, right? So saga, this guy invented saga. Aaron DeFazio et al. He is from Australian University, Canberra. He invented this. These three people. Okay. So what you have to do is you have to read the abstract first. You have to read the abstract and then decide whether this paper is important for you. Okay. First, you read this abstract. We will arrange a session later. Maybe actually Bharti was also asking to arrange a session. We'll arrange a session and discuss it further. But read the abstract first and decide whether some things are understandable to you and whether these things are interesting to you. Once you understand what is there in the abstract, you go directly at the end. Okay, here are some codes which they have utilized. This is the appendix part. Okay, appendix you do not go now. You go experiments. Okay, no. Okay, I think here here they have followed a separate stage, but you have to go to conclusion. Okay, so you go to conclusion, you read the abstract first, then you go to conclusion and you see whether the conclusions are interesting enough to you. There you will get a gist of what the paper actually does. Okay, and then if it is important, if it is interesting enough to you, you start reading from introduction. Okay, then you start on and on. So now if you want to know more about saga algorithm, I am pretty sure you may not be able to get in the old books. This is published when you see. So this saga thing came in, when did it came? 1 minute. Just check the year. 2014. So see, this thing got invented in 2014, man. So if the Bishop book does not have a edition very quickly updated, it will not be there. So you have to go to this archive. You have to, as this is open source now, so everyone can update and everyone can invent something new. So you should go here. First you read the abstract, then you go to conclusion. If conclusion is not here, that's okay. Then you have to read from abstract only. And once that is done, you start from this introduction. Then you this is the basic part. Okay, this is the basic math. But again, this is required when you are coming to your bachelor's is done, then you are coming to the research part. Then that point, these all will be more required. Okay, right now, yeah, again, this may not be required. Up to here will be good enough, I think. And obviously, of course, if you are very interested, why not? You can read. And I mean, there are many research internships coming up. Someone was asking us about doing a lithium ion data analysis internship a few days ago. Okay, So you can read these things. There is no harm in trying. Okay. So that is the best source, and then the other source which are there. And many of the times there will be quite different sources. You know, like one time I saw that the best resource was a biology paper. So then you have to pass through the biology paper, and you have to take which part do you require, and so on. Okay. And each of these have separate references. So all these, so now you are here, you have to pass through you have to see the papers and all. Okay. Sci-Hub is there, you can read for, that's actually for illegally, that's illegal till now. Okay. Now there's a girl called Alexandra Ilbakian, I think. Ilbakian. So she's the great champion of open research. So all those things you can you can check. I mean, what comes behind all these things which we study. Those all things are there. Very interesting stories are there. Okay. Anyway, I'll anyway upload this thing. Let's continue as far as possible. So what we do is we do a regression task for a large scale of data. Let me share the copy this thing, what we are trying to do here. Okay. So then what we do is we obviously we import the data sets. We import train test suite. We make a regression data set of 10,000, 100,000 feature samples and 50 features. And we apply some noise and some random state, and then again we calculate the train test shape, right? Then we calculate we do a reshaping, and we check whether the reshaping has been implemented properly. Okay. And 1 minute. Now that is when it is done, you can check from 900, 150, and etc. etc. So the number of training examples now is 90,000. So what we want is make a chunk of 100 data. Okay. So fine. So what we are doing here is we are calculating the second element, right? Extend shape 2. Okay. Now that is coming to be here. Oh, sorry. Anyway, extend shape. Let me. Then what you can do is you can calculate, you can import numpy, and then we are identifying as train data. We are starting one variable, there we are concatenating the new axis. And okay, let me just check these commands also. Let us know, okay, if you, I'm not getting enough time to explain. Let me know if you face any issues, okay, or do not understand the codes. Well, just let me know in the discourse. I'll try to answer at least. Okay. Some portion we will have to answer. Should answer. So after all these things, what is coming? After all these things, we are applying the standard scalar. And for I in that shape, we are applying partially fit the data in the batches. For I in the range extreme.shape 0, we are applying on the X batch and Y batch. We are applying the partial fit. After that, again, we import SGD regressor, and then we define a SGD regressor as the variable regressor, right? Then for I in the range, we start a loop, right? And then we again partial fit the data. So, and again for j in the range, we do our for the same thing for the train test and the test train x train as the x test. After everything is done, what we are doing is we are calculating the mean square error and the R2 score. Okay, R square value. Okay, so what did we do? I think I did not import. Yeah. Okay. Someone is saying something. 1 minute. Hari, link of this data means which data?
Sir, currently which you are discussing this?
No, we are making a regression. We made a regression file, na? A regression data sheet we made. Just check the codes.
Sir, this is third data, na? Third types of the data you are discussing.
Yeah. So what so we have not introduced any new data sheet. No new CSV file. Okay.
Okay, sir.
Yeah. Then what we are doing is we are importing SDD regressor, and yeah, again we are calculating. Okay, what is the problem? R2 score. R2 score where should be imported? I think that is like anyway that needs to be imported, huh? Just import that, and we have to see where from where we can import R2 score, and you can check what is the MAC. So MAC up to here, MAC is coming to be 101. Okay. So basically, this is the thing which will come. All the what is the R square value, what is the MAC value, this will be asked in the exams, and yeah. So mostly that. And what else is there? Then we can calculate the intercept value and the coefficient value and so on. Yes, here again we are calculating from sklearn.metrics the mean square error and R2 score. So what is the MAC for test and what is the R2 score that we have calculated here? And okay, actually the same thing has been done to answer right now. We'll see what is the difference. Okay. So mostly this is the collab. Okay, I'll share the collab. I'm also I'll share the collab today. Okay, just check it, check the PDF and practice it. There may be some portions, some corrections to be done, right? Like that R2 score, it was not you know imported properly. So that we can do. And another thing is that check these oral questions. This may be I don't think in OP there will be any oral questions. Okay. In Viva there will be, of course. Viva is basically OP plus some oral questions, I think. Okay. And yeah, apart from that, so yeah, it should be same. Okay. And so basic template we understand, right? We have to load the data, we have to do the pre-processing, we have to scale the data, we have to as we were discussing, right? The same things, the imputation, scaling and all those things we have to do. And after that we will go to the next part, that is the SDD regressor, the whatever is there, the linear regression and all other things. So those will be helpful to do. So those will only be asked in OP. So prepare for that. That is, I think, next weekend. Is it the 25-26? Is it so? I think that is the date. Yeah. So just look for that. Prepare for that. Write the codes. Write. I mean, practice the codes. Writing the codes as many times as possible. That will be helpful, I think. Okay.
Sir,
yeah, sure.
Can I ask a question about the partial fit? I don't know if it was discussed in previous session.
No, please tell me.
I went through the documentation of the partial fit.
Scalar documentation.
Yeah.
Is it?
Yeah.
Where?
So it basically says that it set max iter to 1 and do one epoch.
Max iter to 1 and 1 epoch.
And it does 1 epoch. So this is fine when you give a first batch of data. it does this, correct?
Okay.
Then it remembers the weight value and like updates the weight for when you pass the next batch, correct? So this is so my understanding. So then can't we reproduce the same thing with like setting warm start is equal to true?
So basically the question is whether partial fit can be done with warm start equals to true.
Yes. Or like, is it like, it goes over the data again? Like after in the second one, when you pass the second batch, does it go over the first batch of the data? It doesn't, right?
If warm state is not equals to true, then it should not go over the first.
No, not in warm state, in the partial fit.
Let us check here.
No, so SGD regressor has a method called partial fit. So you look at SGD regressor.
Here, sir, somewhere.
Yeah. So if you go down in one of the methods is a partial fit. Further down. Further down. Yeah.
Perform one epoch of stochastic gradient descent on given samples. Internally, this method uses max eta to be 1. It performs one epoch of stochastic gradient descent on the given sample. Therefore, it is not guaranteed that a minimum of the cost function is reached after calling it once. Matters such as objective convergence and early stopping should be handled by the user. Okay. So so even if we use it once, it will not minimize the cost function. Now, sir, what was the question?
So I think so. When you say one epoch, you have to go over the entire data, right? To you have to update the weights over the entire data to call it one epoch, right? So
yes.
like in the so this happens in the first iteration, that I understand.
Yes.
Now if you give the second iteration, you give the next batch of data, right? So now does it go over only the second batch which is now given, or like over the entire data we have? Right?
Over the entire data that we have given before.
It will go over the entire thing.
I don't think so, Vishwajit, because then it will again add to the time and the cost. So yes, I think it takes only the second batch and then runs the model.
Yes. So in that case, there is no difference between warm fit and warm start. True, right?
No, that this is just a fit, right? Okay.
So even I understood that it only takes in batches.
Okay.
So I mean, every batch is treated separately as a data set, and it conducts the whatever you do, the scalar and the fit of your model on that particular batch. But whether it goes through the all the batches again, that's confusing. I didn't understand. What I understood from the lectures is treating every batch as a separate data set. And that's why you have that number of iters, and for every batch you have a separate coefficient and intercept. So that was my understanding.
Vishwajit, can you just
actually here there is no batch, there is only epoch. And so let's say there are multiple cases here. Let's say we initialize SGD regressor, simplest case. Let's start with the simplest case. SGD estimator, regressor classifier, whatever, with max setter set to some very high value. And you give it, let's say the iris data set, which has 150 samples. It's going to keep on repeating on the same 150 samples. Now that 150 samples together is one epoch, right? And that you keep doing until it converges, right? That is the simplest way of using multiple things. The other way of doing it is simply do partial fit, right? If you do partial fit, it's going to take the whole 150 samples at a time and update the weights. And partial fit implicitly means that warm start is true. And it will ignore max
Okay.
hitter.
Oh, okay.
Now, ignore the max hitter.
Max hitter, because partial fit will only do one epoch, nothing else.
Okay. Okay.
And since it is implicitly warm start equal to true, it will update the weights. It will not rewrite the weights.
All right.
Now, the third way of batching it, which could be like you shuffle the data set and say there are 150 samples, I'm going to give 50 at a time. So your epoch now becomes of size 50.
Okay. Okay,
Now
so you go
that-
over each batch, and that is called one epoch.
Exactly. So typically, in common terminology, when we say epoch, that is your entire data set. At a given time, it can be split into batches. There is no explicit batch support in scikit-learn. There is only epochs. So if you want to do it by batch, you will have to call partial fit on separate slices of the data.
All right. All right. So basically, you're saying that warm start is equal to true, and if I do that procedure and also partial fit with batches, you'll get the same result. Right?
You should get the same result. Either you do partial fit or you do warm start and then call fit.
Okay, I shouldn't experiment on this really.
I have another doubt.
It should be the same thing, and it should essentially give you the same thing. And basically, partial fit is sort of an alias for max hitter equal to 1 and warm start equal to 2.
Okay, okay, that makes sense. Thank you.
Basically, when I run the second batch, it already remembers what happened in the first batch and then implements second batch results into it itself.
So all it has to remember is the coefficients and the intercept.
Yeah,
and
yeah.
It's already done that. Now, if you call fit every time, it's going to reinitialize those things to random weights and then start again. But in the other cases, it's going to update. It's going to use update the same existing weights. It won't reinitialize it to random or zeros or whatever it does.
Okay, okay.
Yeah, I have another doubt. If you want to scale it, so how do you scale the data and then store it separately and then run the fit? I mean, if you do it batch wise, will it work? If I do a scaling every batch?
Actually, this morning itself, while doing the week 7 assignment, I had the same question. I was actually very surprised to find out that standard scaler has a partial fit. But it turns out that you have to do an entire pass over the large data set chunk wise to make your scaler to do partial fit so that it has learned the mu and
Yes.
sigma. And
But
then
how do you
a
store
separate
that
pass
data?
again.
Because it's it's an object we have not in this assignment. We have not learned about this text object, whatever it is. So I can't even see the data. I have to run an iterator to batch wise to actually see the data also.
No, what text object?
So this it's giving some. I'll tell you what. It's the object is not coming as a data frame for me.
It will be probably an umpire array or a sparse matrix, right?
No, it's
Is
giving
it text data?
Yeah, it's text data. It's coming as text file reader. So the object
Oh, I
is
see. Okay. Got it. So this is basically the pd.read CSV with iterator set to true.
Yes, with the iterator set to true. Right.
But if you specify a chunk size, you will get a data frame.
Jaydev, one question here. You have used scalar.transform x underscore batch, and then you have used x underscore batch. Have you tried printing what was the value of x underscore batch before scalar underscore transform and what you are passing it? I believe that it will be the same value because we have to save scalar.transform x underscore batch in some variable and then you have to pass it.
Correct. Yes, that has to be done because how will the scalar remember the scaling parameters? So that's why the partial fit on the scalar has to be done. You do an entire pass. You do the partial fit only for the scalar. Then you set that scalar aside. Next time you do an entire pass, this time it is for training and scaling. So this time you do only transform. You don't do a fit or a partial fit on the transformer. So you have to run 2 iteration loops, essentially. One for fitting the scalar and the other for doing the training and the transformation via the scalar.
But when we have to transform, actually, we will be doing that in partial fit case of the estimator, right? So
No, exactly. That's the problem, right? Because if you start, let's say I'm only reading the first 100 rows of some data set and I do a fit transform based on that itself. Now, what if the subsequent samples in the data set have some really weird distribution? This scalar has never picked that up, right? So I can't do a transform at that stage. It has to go over the entire thing.
No, the same thing. I probably I might not have stated it clearly. So there is one loop which actually go by partial fit, but it will go through complete set of the data, so that entirely that partial fit actually pass through the whole data. So now I have the scalar function, which is fitted over the whole set of data, but in chunks, chunk 1, then chunk 2, chunk 3, like this.
Yes.
Now in the next loop, again, starting of the data set, I will be doing partial fit with respect to estimator now. And in the estimator,
no. If you're doing the pass the second time, why would you do a fit again? Because it's already fitted. Now you only do transform.
No, I have to do this fit for the estimator now.
For the estimator, yes. For the transform, no. Yeah.
So I'm talking about the estimator. So even in the first loop, I haven't transformed anything. I have just fitted it. Now, on that fitted scalar thing, now I will use transform in the second iteration, because now my my fitted scalar model is there. Now I will use scalar dot transform, and then the whatever the chunk I am in, x underscore train, and then the y underscore train in the estimator value, and then it will go chunk by chunk, and then at the end I will get
what you're doing is you are fitting the estimator before transforming.
No. In the second loop, I am doing this. In the first loop, I have already completed the scalar thing.
Scalar, okay.
But I haven't used a transform in the first in the first thing, because
correct, because the scalar is not complete. It has to still fit a lot of things. Right.
Now, when I'm using it in the second loop, which is not inside the first loop. First loop is different, and second loop is different. So, independent. So in the second loop, when I'm going through the data again, in order to fit the estimator through partial underscore fit, I am passing this transformation value with respect to the scalar that I have obtained after completion of the first loop.
Correct. This is correct. Yes.
Right. So, but answers are not matching here. I don't know.
No. Same happened for me. There is something wrong with that, because I think somebody mentioned this. If you're doing standard scaling, then ideally your intercept should be 0.
I am the one who actually mentioned that.
Perfect. Exactly. That's you are right. The values for the coefficients are super high, 10 raised to the power 8 and all that. That seems incorrect. In general, if your data is normalized, your coefficients should have an L2 norm of less than 1.
Yes.
Is it this
and
question?
Your intercept has to be 0, or at least very close to 0, because if it is not 0 and if it is some crazy high value, that clearly means that your data is not normalized, right?
Actually, I was able to generate these high values without the transformation. So that's why I got this hint that, okay, probably...
Perhaps something got commented out or ignored when when creating the solutions. But actually that is interesting, because I tried to do it without transformation. I was still not getting very high values. No, I was still getting like reasonable values.
Is it this question where there are 90,000 samples or so on?
Yes. I think it is that lat long question, if I'm not wrong.
I have to check. So one question there, huh?
Yeah, it's the what
so question number 6 to 8.
6 to 8, right?
Yeah, only out of that, only one is definitely answerable. The sample size one, the other two are
exactly.
They have some really weird answers.
Okay, Jaydev, can you just post to us? I mean, maybe we have to reevaluate. Okay.
Yeah, it's already there is a long thread on it. If you just look at
can you just tag me?
I'll do that.
Week 6 to 8, question 6 to 8, is it?
Question 6 to 8, yes. Basically, out of that, question number 7 and 8 are the ones that need to be rechecked. The answers to that, the options that are given, they are not making sense.
Or if the answers are correct, then probably question need to be corrected in such a way that
maybe question 7, 8, question 7, question 8, and question 6.
That's all.
Question 7, question 8 answers to be rechecked, is it?
7 and 8 only, yes.
Achha. Question 7 and 8, right? Question 7 and 8 answers to be rechecked. Okay. Okay, anyway, I'm sending it. Huh?
Jaydev, what you say about the fit actually makes perfect sense. But like in the collab, in the lecture collabs, the sir has actually done fit transform again in the second iteration.
That is wrong, unfortunately. And I think this is a debate I've been having with a lot of people over a long time. That is just plain wrong.
So in the collab,
Once you
when
don't do
use
fit
hashing
transform on repeatedly every time, because if you
No,
do
that
that,
may
you're
happen. Wait. Which collab?
So in the lecture, when you're using hashing vectorizer.
Wait. 1 minute.
oh, okay, sorry. If you're talking about hashing vectorizer, then I don't know.
Yeah, that's why
I
I
was
asked the
talking
question
about
also, because I
okay. That may be a different behavior entirely. I was talking about things like standard scalar and PCA and other stuff. Hashing vectorizer, it's possible.
Yeah.
Then I take that back. Hashing vectorizer, it's possible. I'm still not sure. It's possible that what was shown was correct.
Yeah, that I completely agree with you. The PCA problem was there in the assignment as well in week 5.
Week 5, I corrected 4 questions. 4, 5, 7, 8 are wrong. I think were wrong. That I have corrected. Yeah. 1 minute. Yeah, I told about the question 7 and 8. Okay, they will get back. I think in the revaluation they will get back.
Thanks a lot.
Yeah. Yeah. Anything else? I mean, what you think, sir? If sir has done, I mean, some portion is wrong or something, na, it may happen. Okay, because as I told, I mean, there's just one day he is recording and the next day we're uploading, so there's a lot of things can happen. Just do you have my email ID or phone number?
No, sir, if you can share it, then probably we can
I'll
send you the
share
file.
my or is just let me know in Discord. I mean, in email, if you also send, then it's problem. I mean, I have to track all the emails. Jaydev, just I don't know. I'll just give anyway. Best way is anyway to do.
No, it's okay, Debajyoti. There's
Yeah.
no. I mean, you're
Yeah, just let me
sufficiently
know.
tagged on discourse.
Yeah. No, but from next week onwards, I won't be taking live sessions. So maybe Jimmy will be taking. So then he will be the main person answering. Anyway, just let us know which part actually sir has mentioned that I mean it is which you think is wrong, okay, and why it is wrong. Then we can actually tag sir also, because what may happen is that the collab was made by us and sometimes it may happen that there is a mistake. I have found like that thing which Anand also was telling na, that the code is running for 48 minutes. I mean, it should not run. I mean, that's a bad thing. Na? So just let us know. We'll upload. We'll do something. I mean, maybe I don't know. In recording, something can be overlapped, or I don't know. Something we will try to do. Okay, or maybe some discussion on the thing. Okay, I have already sent this solve with instructor file for upload. Okay, that will be uploaded by Monday. I think tomorrow is holiday. Yeah, just see that. Let me know if anything else is happening. If anything else is required, we'll upload it. Okay. Okay. Chalo, let's end it here. Have a nice weekend, everyone. Yeah. Okay. Bye.
Thank
Bye,
you,
guys.
sir.
Yeah, sure. Bye, sir. Thank you.